In the vast expanse of our solar system, far beyond the familiar terrestrial planets, lies the ice giant Uranus. Among its moons is Caliban, a small enigmatic moon discovered in 1997. Named after a character in Shakespeare's The Tempest, Caliban hints at the mysteries surrounding this celestial body. Our exploration of Caliban will unravel its unique characteristics and its place in the grand tapestry of the cosmos. Uranus boasts a remarkable system of 27 known moons, each with its own story to tell. These moons are broadly classified into 3 categories: the 13 inner moons, 5 major moons, and 9 irregular moons. The 5 major moons, including Miranda, Ariel, Umbriel, Titania, and Oberon, are large enough to have achieved hydrostatic equilibrium. Finally, the irregular moons, including Caliban, are characterized by their distant, eccentric, and often inclined orbits. The diversity of Uranus's moons offers a unique opportunity to study the processes that govern the formation and evolution of giant planet systems. Caliban's story begins in 1997, when a team of astronomers discovered this faint moon using the Hale telescope at Palomar Observatory. Caliban's faintness, a testament to its small size and dark surface, had made it elusive to previous observations. The discovery of Caliban, along with other irregular moons like Sycorax and Prospero, challenged existing theories about the Uranian system. These distant captured moons suggested a more dynamic and complex history than previously thought. Caliban circles Uranus at an astonishing distance of approximately 7.2 million kilometers. This immense separation means that Caliban takes its time completing one orbit around its icy giant host, taking 579 Earth days. Unlike the inner moons of Uranus, which follow relatively circular paths, Caliban's orbit is distinctly elliptical. This eccentricity is a telltale sign of Caliban's likely origin as a captured object. Caliban's orbital eccentricity provides compelling evidence for its capture from the outer solar system. Captured moons like Caliban likely originated in the distant reaches of the solar system, perhaps even beyond the orbit of Neptune. Other irregular moons of Uranus, such as Sycorax and Prospero, also exhibit highly elliptical orbits, suggesting a shared history of capture. Caliban exhibits retrograde motion, meaning it orbits Uranus in the opposite direction to the planet's rotation. Retrograde motion is another strong indicator of Caliban's capture origin. Caliban's retrograde motion, combined with its eccentric orbit, paints a picture of a celestial object with a turbulent and dynamic past. By studying Caliban's orbital characteristics, astronomers can piece together clues about its origins and the history of the Uranian system. The combination of its extreme distance, high eccentricity, and retrograde motion strongly suggests a capture origin. Caliban's presence provides valuable insights into the complex gravitational interactions that can occur within planetary systems. Its composition, believed to be primarily water ice and rock, provides additional support for its capture origin. Caliban appears as a faint point of light, even to the most powerful telescopes. Astronomers estimate Caliban to be approximately 72 kilometers in diameter. Despite its diminutive stature, Caliban's surface likely holds valuable clues to its composition and history. Its low reflectivity suggests a surface composed of dark carbonaceous material mixed with water ice. By analyzing the way Caliban reflects different wavelengths of light, scientists can identify the presence of specific materials. These spectral fingerprints reveal that Caliban's surface is primarily composed of water ice, mixed with darker materials. This reddish tint suggests a shared origin and exposure to similar space weathering processes over billions of years. The presence of both water ice and dark carbon-rich materials on Caliban's surface paints a picture of a world shaped by a combination of internal and external processes. Caliban bears the scars of a long history of impacts. Each impact would have left its mark on Caliban's surface, creating craters of varying sizes and shapes. These impact craters are valuable records of the solar system's history. By studying Caliban's crater record, astronomers hope to piece together a more complete picture of the processes that shaped our cosmic neighborhood. One of the most intriguing questions surrounding Caliban is whether it exhibits any signs of geological activity. Most icy moons in the outer solar system are thought to harbor subsurface oceans of liquid water. While there is currently no direct evidence of a subsurface ocean on Caliban, its composition and location make it an intriguing target for future exploration. The discovery of any form of geological activity on Caliban would have profound implications for our understanding of the potential habitability of icy moons. In the grand, intricate ballet of the Uranian system, Caliban may seem like a minor player. However, Caliban plays a crucial role in our understanding of the system's history and evolution. Its unusual orbital characteristics and composition provide clues to the dynamic processes that shaped the Uranian system billions of years ago. By studying Caliban and its counterparts, astronomers can piece together a more complete picture of the material that coalesced to form the giant planets and their accompanying moons. Section 2. Gravitational Choreography. Caliban's influence on its neighbors. While Caliban may seem like a solitary wanderer in the outer reaches of the Uranian system, its gravitational influence, though subtle, extends across the vast distances, subtly tugging at its neighboring moons. This gravitational dance, a complex interplay of forces, shapes the long-term stability and evolution of the entire system. Even small perturbations in a moon's orbit, accumulated over millions or even billions of years, can have significant consequences, potentially leading to orbital resonances, collisions, or even ejection from the system entirely. Consider the concept of orbital resonance, a phenomenon where two or more celestial bodies exert a regular, periodic gravitational influence on each other due to their orbital periods being related by a ratio of small whole numbers. These resonances can act as stabilizing forces, locking moons into specific orbital configurations, or they can have the opposite effect, amplifying small perturbations and leading to chaotic interactions. Caliban's eccentric and inclined orbit, combined with its relatively long orbital period, means that it does not currently participate in any known orbital resonances with other Uranian moons. However, its gravitational influence, though weak, cannot be ignored. Over long timescales, Caliban's gravity may contribute to the long-term stability or instability of the Uranian system, subtly influencing the orbits of its neighboring moons. A shared history. Caliban and the irregular moon population. Caliban is not alone in its distant dance around Uranus. It belongs to a family of irregular moons, celestial objects characterized by their distant, eccentric, and often inclined orbits, stark contrasts to the more orderly, nearly circular orbits of the inner moons. These orbital characteristics, shared among Caliban and its irregular siblings, hint at a common origin, a story of capture from the outer solar system, where icy remnants of the early solar system still reside. Imagine the early solar system, a chaotic environment teeming with planetesimals, icy remnants from the initial cloud of gas and dust that gave birth to the Sun and the planets. These planetesimals, ranging in size from small pebbles to dwarf planets, interacted gravitationally with each other and the newly formed giant planets. Some were incorporated into the growing planets, while others were scattered outward, forming the distant populations of icy bodies we observe today, such as the Kuiper Belt and the scattered disk. Caliban and its fellow irregular moons are thought to be remnants of this early scattering event, captured by Uranus's gravity as they wandered too close to the ice giant. Their diverse orbital characteristics reflect the chaotic nature of their capture, with each moon carrying a unique record of its journey from the outer solar system to its current home in the Uranian system. Planetary formation unveiled. Insights from irregular moons. Irregular moons like Caliban offer insights into early solar system formation and the protoplanetary disk. Unlike major moons, irregular moons were captured, revealing outer solar system dynamics. These moons provide a glimpse into the composition and dynamics of the outer solar system. Imagine the protoplanetary disk as a cosmic kitchen, mixing ingredients for planets and moons. Caliban and its fellow irregular moons link us to the outer protoplanetary disk. The future of Uranian studies, Caliban's place in the grand narrative. As we continue to explore the cosmos, Caliban and the Uranian system as a whole remain tantalizing targets for future missions. While our current understanding of Caliban is limited by its distance and the capabilities of our telescopes, future missions equipped with more advanced instruments could revolutionize our view of this enigmatic moon and its place in the Uranian system. Imagine a future mission to Uranus, a spacecraft specifically designed to study the ice giant and its diverse family of moons. This mission could include a dedicated orbiter equipped with high-resolution cameras, spectrometers, and other instruments capable of studying Caliban's surface composition, mapping its geology, and searching for signs of past or present activity. Such a mission could also deploy a lander to Caliban's surface, allowing for in-situ measurements of its composition, temperature, and other properties. The data collected by this hypothetical mission would provide unprecedented insights into Caliban's formation, evolution, and potential for harboring the ingredients for life. Furthermore, by studying Caliban in the context of the Uranian system as a whole, we can gain a deeper understanding of the processes that shaped our solar system and other planetary systems throughout the cosmos. Eyes on the skies, telescopic observations of Caliban. Our understanding of Caliban, like many celestial objects in the outer solar system, relies heavily on the power of telescopes, our eyes on the cosmos. These technological marvels, perched atop remote mountains or orbiting high above Earth's atmosphere, allow us to peer across vast distances, capturing faint glimmers of light from worlds billions of kilometers away. However, observing Caliban presents a unique set of challenges. Imagine attempting to discern a firefly hovering next to a brilliant spotlight, all while standing hundreds of kilometers away. This analogy, though seemingly extreme, captures the essence of observing Caliban. Its diminutive size and faintness, combined with its proximity to the much brighter Uranus, make it an exceptionally challenging target for even the most powerful ground-based telescopes. Despite these challenges, astronomers have employed ingenious techniques to extract valuable information from the limited light that Caliban reflects. Adaptive optics, a technology that corrects for the blurring effects of Earth's atmosphere, has significantly improved the resolution of ground-based observations, allowing astronomers to resolve finer details and study Caliban's motion with greater precision. Beyond the visible, unlocking secrets with spectroscopy. While images captured by telescopes provide valuable information about Caliban's position, brightness, and motion, they reveal little about its composition and surface properties. To delve deeper into the nature of this distant moon, astronomers turn to spectroscopy, a powerful technique that analyzes the light reflected from celestial objects, revealing their chemical fingerprints. Imagine passing sunlight through a prism, separating it into its constituent colors, a rainbow of wavelengths. Just as each color corresponds to a specific wavelength of light, each chemical element and molecule absorbs and emits light at specific wavelengths, creating a unique spectral signature. By analyzing the spectrum of light reflected from Caliban, astronomers can identify the presence of specific materials based on their characteristic absorption and emission lines. Spectroscopic observations have revealed that Caliban's surface is primarily composed of water ice, a common constituent of objects in the outer solar system. However, the presence of subtle absorption features in Caliban's spectrum hints at the presence of other compounds, potentially organic molecules, adding another layer of intrigue to this distant moon. Section 3. The Voyager 2 Legacy. A fleeting glimpse of Uranus and its moons. In 1986, humanity's first and, as of now, only mission to Uranus, Voyager 2, provided a fleeting but invaluable glimpse into the Uranian system. This robotic explorer, launched by NASA in 1977, embarked on a grand tour of the outer solar system, sending back breathtaking images and scientific data that revolutionized our understanding of these distant worlds. While Voyager 2's primary mission focused on Jupiter and Saturn, its flyby of Uranus in 1986 provided the first detailed observations of the planet's rings, atmosphere, and moons. However, Voyager 2's encounter with Caliban, discovered almost a decade later, was a distant one. The spacecraft's instruments were not designed to study such faint and distant objects, and Caliban appeared as little more than a faint smudge in Voyager's images. Despite the limitations of Voyager 2's observations of Caliban, the mission's legacy extends far beyond its initial flyby. The data collected by Voyager 2, particularly its measurements of Uranus's gravitational field, provided the foundation for later discoveries of new moons, including Caliban. Moreover, Voyager 2's observations ignited the imagination of scientists and the public alike, inspiring future generations to explore the outer solar system in greater detail. Section 4. A Call for Exploration, Future Missions to the Uranian System. While telescopic observations and the legacy data from Voyager 2 have provided valuable insights into Caliban and the Uranian system, many questions remain unanswered. To unlock the secrets held by this distant moon and its icy companions, a dedicated mission to Uranus is needed. Such a mission, equipped with state-of-the-art instruments, could revolutionize our understanding of this ice giant and its enigmatic moons. Imagine a future spacecraft, specifically designed to study Uranus and its moons, orbiting the system for years, collecting detailed data on their atmospheres, surfaces, and interiors. This hypothetical mission could include a high-resolution camera capable of capturing the intricate details of Caliban's surface, revealing the presence of craters, ridges, and other geological features. A dedicated mission to Uranus could also deploy a lander to Caliban's surface, allowing for in-situ measurements of its composition, temperature, and other properties. A seismometer placed on the surface could listen for moonquakes, providing insights into Caliban's internal structure and the possibility of a subsurface ocean. The data collected by such a mission would not only deepen our understanding of Caliban, but also shed light on the formation and evolution of icy moons throughout the solar system. Section 1. Curtain Call: Reflections on a Distant Moon. As we draw the curtain on our exploration of Caliban, this small, distant moon orbiting Uranus, we are reminded of the vastness and mystery of our cosmic neighborhood. Caliban, named after the enigmatic character from Shakespeare's The Tempest, holds secrets yet to be fully unveiled. Its discovery in 1997 challenged our understanding of the Uranian system, revealing a more dynamic and chaotic past. Caliban's eccentric orbit hints at its capture from the outer solar system. It speaks to the gravitational dance of celestial bodies, a ballet played out over billions of years. Its reddish hue, a result of water ice mixed with dark carbon-rich compounds, hints at its formation in the cold, distant reaches beyond Neptune. Remnants of the early solar system still reside there. Our knowledge of Caliban is limited by its distance and our telescopes, but each new observation brings us closer to understanding its story. Despite its small size, Caliban plays a crucial role in our understanding of the Uranian system and the broader context of planetary formation. Its presence, along with its fellow irregular moons, provides valuable insights into the chaotic early solar system, a time of collisions, captures, and planetary migration. By studying Caliban, we delve into the history of our cosmic neighborhood, piecing together the events that led to the solar system we observe today. Section 2. The Final Act, Unwritten Chapters in Caliban's Story. Caliban's story, like the cosmos itself, is still being written. Many questions remain unanswered, mysteries waiting to be unraveled. Does Caliban harbor a subsurface ocean hidden beneath its icy crust? Answering these questions will require a dedicated mission to Uranus. Imagine a future spacecraft orbiting Uranus, its instruments trained on Caliban. The exploration of Caliban is far from over,